Hello everyone. Today first we will learn about the multiplexer. So multiplexer is a combinational circuit that selects binary digital information from one of many input lines and direct it to output lines. Suppose you have a system that can only receive with one line, but from the environment or from other device you have four different lines with four different data, but your system can receive with only one line. So in this case what you will do, so you need another system which can handle this four line and which can connect each of this one to a single output line. So suppose we can name it like W1, W2, W3, W4. So when this system is needed this W1 data, so this system will connect this line to this one, and next whenever this system is needed this W2 data, so this will go on and this will connect to this one. Similarly this will go to this one and this will go to this one. But how this line will be selected? So that's why we need a selector pin. So suppose we can give this name as a S0 and S1. So if this system can control these two lines, and by controlling these two lines it will select W1, W2, W3 or W4. So if it's gives 0 0 over here, so then W1 will be selected, and if it gives 0 1 then W2, 1 0 then W3 and 1 1 W4. So this actually system is called the multiplexer. So what is doing? It is actually a data selector. It's working as a data selector. So whenever your need is W1, you have to select 0 0 and W1 will be connected to this output, and this system will get this W1 data. So as it has four inputs and one output, that's why we are calling it 4 to 1 mux. So often mux is written by like this, mux MUX multiplexer. So the full form is multiplexer, but we write this thing as a MUX mux. So now another question is that how you will know how many selection pin do you need? So there is a very simple equation. If the number of select line is m and number of input is input means input line is n, then m is equal to log 2 base 2 actually m. So in this case we have four inputs, so we can write it like this, log 2 4, and this can be written as log base 2 to the power 2. So we can rewrite this one like this, 2 into log 2 base 2 2. So this is actually 1. so 2, so we need two selection lines. So here you see we have two selector line. So this is actually the basic concept of marks. And if you say what what are the types of marks, so you have like 2:1, so which is called like 2 to 1 marks, then 4 to 1, like 8 to 1, 16 to 1, 32 to 1, like this. So these are the most commonly used multiplexer, and the advantage of this multiplexer are like it can reduce the words. So previously we are using lots of basic gates to complete a full combinational circuit, but by using this only this multiplexer IC, you can reduce lots of logic gates. So it can handle many logic gates, and it can all simplify that logic gates with a just using a multiplexer. And also it can reduce the circuit complexity. So if you have more logic gates, so it will become more complicated. So if you can solve it with a multiplexer, so it's best to use the multiplexer. And you can implement various circuit also by using only marks. Like in the future we will talk about some adders, so you can make a adder system with multiplexer, and mostly it is used in the data selection line. So if you have if you need to select from multiple data to one line, so multiplexer is used oftenly in here. So now we will design our 2 to 1 marks. So how it works, and from truth table how can we derive a circuit of a 2 to 1 multiplexer. So in 2 to 1 multiplexer, you have only one selection pin like this, one selection pin, and maximum you have two inputs. So you can write it W0 and W1, and this is one output. So what will be the truth table? So this is our selection pin S, and this is F, the output. So when it will be 0, then W naught will go to output, so the output will be W naught. And when it is 1, then W1 will be output. So we can write this like this one. So if this is S naught, right? So when S is 0, that means S bar. And if we connect the input to this one, which is input is W0, so we will get the W at the output. Or F will be like when S is 1, that means S, and W1 is ANDed with this S, then we'll get W1 to this output. So from this we can derive the circuit. So you have W over here, so it will go to a with the S bar. So if we have S over here, so we need an inverter over here. So these two are ANDed, right? Okay. And next one is W1 and S. So there will be another AND gate, and here we will have the W1, and these two are OR. So this is our F. So you can clearly see that So if we give 0 over here, and here it will become 1, and if you give 0 over here, so this is 0, so 1 and 0 gives 0, and as this is right now is 1, right now is actually 0, sorry, 0, and this is also 0, so 0 0 output is 0, and this 0 actually you will get 0 over here, and if you change it to 1, then you can see 1 1 is 1, so it will become 1. So when 0 is selected in S, so output will be totally dependent on W0. So if W0 is 0, then the output will be 0. If W0 is 1, then output will be 1. Similarly, if you give 1 over here, the output will be totally dependent on W1. So in that case, if W1 is 0, the output will be 0, and the W1, if the W1 is 1, then output will be the 1. So similarly, you can, for 4 to 1 mask, we can write the function so 4 to 1, if this is W0, W1, W2, W3, and this is actually your Y, and you have two selection pins, S0 and S1, then Y will become S1, S0, bar, and this, if both are 0, then what will be the output? W0. So W0. Or if S1 is not, that means if this is 0, this is 1, then W1 will be output, and then if this is 1 and this is 0, then W2 will be the output. And for this case, both are 1. So this is the function actually for 4 to 1 marks. So these are actually the basics of 2 to 1 marks and 4 to 1 marks. So how it is developed with using just combinational circuit like AND gates and OR gates. Now we will talk about the demultiplexer. So demultiplexer, often we write it like demux, and demux is actually the inverse of multiplexer. So initially in multiplexer we had multiple input lines. Now there will be one input lines and there will be multiple output lines. So like this. There is multiple output. So this is actually 1 to 4 demux. So we have 1 input lines and 4 output lines. So for this case we also need some selection pin, and depending on the selection pin, this line will be connected to either to this one or to this one or to this one or to this one. So if we make it like this, output y0, y1, y2, y3. So the equation is same for selecting the pin. It will depending on the output. So we have two output, S0, S1. So if you make it 0 0, so the input line will be connected to this one, and similarly if you make it to 0 1, then input line will be connected to this one. For 1 0, input line will be connected to this one, and 1 1, it will connect it to this one. So now we will design a 1 to 2 line demux. So like this. So we have one input line and two output line. So this is y0 and this is y1, and we can make it with one selection pin, so which is S. And if you see the truth table now, and we can make it W, so S we have, but now we have multiple output, so y0 and y1. So when S is 0, the y0 will be W, and when S is 1, so y1 will be W. So we will have two different function, actually output function. So y0 is equal to, this is S0, so S bar and W, and y1 is equal to S W. So very similar. So if this is our output, so actually these are actually our individual outputs. So now if we want to make circuit from this one, then this is our W, the data line, and in this case we have S, and from here we need a inverter, and it will goes to the AND gate. So this is our y0, and for y1 we also need to draw a circuit. So from here W goes to here, this one goes to here, and this will become our y1. So depending on the S, W will come to y1 or y0. So this is actually our demux circuit, and this is our 2 to 1 multiplexer or mux circuit. Now if you see the lab report, you will find that we have different kind of multiplexer ICs. So first of all, this is actually 74151. This is 8 to 1 line multiplexer. So it has 8 inputs and 1 outputs. So inputs are denoted like this one, I0 to I7, and as it has 8 input lines, so we need at least 3 selector pins. So these are the selector pins, so S0, S1 and S2, and Y is the output line and Y bar is the inverse of the output line. You can see over here there is an inverter over here, and in real case or in real scenario, all the multiplexer or demultiplexer has an enable pin. So this enable actually enables the output. So you always you have to make it, or you have to connect this E pin to the ground. So if this is not connected to the ground, the output will be not shown, and if it is connected to the ground, then you can see the output correctly. And this is VDD. So VDD is the power and VSS is the ground. So you need to connect these two to the ground. And this is actually 74153. This is a dual 4 to 1 line multiplexer. So it has two 4 to 1 line multiplexer. This is one input line, this is another input line, and this is the output line of these inputs, and this is the 2y is the output lines of this input, and A and B is the selected line. And this 2G and this 1G need to be grounded to operate these ICs. And the last one is 74157. It has actually 4 2 to 1 line multiplexer. So in the next part actually we will do our lab tasks. So today's lab task is design a 2 to 1 multiplexer, which we already designed the circuit, but we will now implement in the Proteus. Same case to 1 to 2 demux, and then this one. So this one is simple because in the earlier lecture we already know about the K-map. So we will simplify that circuit, and we will know how to make that circuit using only multiplexer, 8 to 1 multiplexer. So thank you all.